hard drive. Okay, perfect. Here we go. Okay, so here's what we're going to do. Always, the first step, look for common factors. Yeah, like this. Yeah, that's exactly what we're going to do. But the first thing I would always do, look for common factors. That's always the essence of, always the first step of factoring. So for part A, you have two terms, right? You have a 5x squared and a negative 45. Is there a factor common between those two?
5.
Pull it out. When you pull it out, what's left behind? Perfect. X squared minus 9, right? Because you're dividing it just by 5. So factoring really, in many ways, is division. If you think about it, we're going to talk more about division between polynomials in chapter 5. But for now, yeah, just pull the 5 out. You got that. Now, can I go further? Because the instructions should have said factor completely. So could I break this down even more?
Yeah.
I could. Do you guys remember how to break that down? Yeah, this case, this is more a memorization thing, I would say. Like you have to recognize. So generally speaking, off to the side here, this will always work if A and B, sorry, A squared and B squared are perfect squares. So we call this, I'm not sure if you guys remember, difference of two squares. Because if you think about it, is 9 a perfect square? What's square of 9? Yeah, perfect squares mean when you take the square root, it comes out as an integer. It comes out nice and clean. Like, is 8 a perfect square? No, I mean, I know square is root 8 or 2 root 2 if you want to simplify it, but it's not an integer, right? Or 7. Root 7 is not an integer, but root 9 is. Root 9 is 3. And x squared, if I took the square of x squared, I get x and x, right? Because what's x times x? X squared. Exactly. So, yeah. Now, why are we spending the time doing this? You need this as a skill to help you with the more advanced stuff you do in pre-calculus and calculus. Actually, it's funny. I met with one of my former students. He graduated from Burlingame High School last year, and I tutored him when he was like in 8th grade, 9th grade, and we did all his factors. And now he's taking calculus, and he needs some help. And we had to do some factoring for some of the calculus problems. So this is why we spent all this time doing factoring, because you need this as a skill set to be able to do the more advanced problems you do down the road. So it's got to be something that's going to be second nature. Like by 2 years from now, someone says factor it, you got to do it fast. Like you do anything, you just do in the blink of an eye. But you guys are still kind of getting your bearings with factoring. So if you're a little slow at that, that's okay. But we're going to do a lot because you need to be really good with it in the next few months. So that's that one. Okay, part B. Is there something common among all three? 3, pull it out. It's going to make your life so. Oh, 3x. Thank you, Hugo. Touche. There you go. 3x. X squared plus. We'll come afterwards. X squared. What else? And Hugo asked this question about 5 minutes ago. Well, negative 14, right? Okay. So great. I pull out a common factor. Is it complete? Is there more I could do? There is more you can do. Now, here's the part that I'm going to show you guys. That there could be a variety of techniques. Now, let me get rid of this on the bottom. If you want to do trial, if some of you can just see it, like I know it's going to be this. I'll show you another technique. But because I've done this for a living for 20. I do this every day for the last 21 years. So yeah, I say 21 years because that's when I started grad school and started tutoring and teaching. I just know that's what it is. But what if you don't know? Then this is what you could do. If you're stuck, so there's one technique called the diamond method. I don't know. It doesn't look like a diamond. I don't know why it's called diamond or X method, or yeah, or if you want to call it X factor. You like that? No, you don't like that? Oh, all right. Okay. Anyway. So what you do this, you put -4. I like doing like this. I put a times c up here. Because remember, generally speaking, quadratic functions are written like this in a standard form. Ax squared plus bx plus c is a standard form for quadratic functions. A is a coefficient of x squared, b is a coefficient of x, c is a constant. Of course, I don't see anything in front of x squared right now because I already pulled out the 3x. So my a is 1, my b clearly is 5, and my c is clearly -14. So I put a times c up top and b in the bottom. Now my task, I'll write this is a text box. So in case you guys forgot, your task is to find two numbers that multiply to -14 and add to 5.
Wait, so which one's A?
It goes in order.
Alphabetical order, numerical order.
Oh,
Not numerical order, sorry. Alphabetical order. 1, 5, -14.
Oh.
Ax squared plus bx plus c. So that should be hopefully intuitive.
So then, x method, wouldn't you go on both sides, you go divided by x? Like after,
So what do you mean by ax?
like let's say that ax here a value, and then you get the two numbers, you go divided by a, and then you're like.
That's a more advanced. Let's hold on to that thought. I know what you're talking about, but because right now we already pulled out a 3x, so we have a more simple quadratic.
Yeah, no, it's just for.
Yeah, we'll come back to that in a few minutes. Let's hold on to thought. Elizabeth, go ahead.
I learned to just like look at it and like write that, like write the most like the factors of
Sure.
the add, and then just like
That's what I'm gonna do right now.
oh,
I'm doing it. Okay,
because I just never learned that.
it's just a way to organize. That's all it is. But you got the gist of it. All right, so guys, quiet down, please. So what two numbers multiply -14 out to 5? 7 and -2, exactly. 7 and -2 are the two numbers. And sorry, I crossed my 7s because they don't look like 2s. So 7 and -2 clearly multiply. So there you go, x plus 7.
Don't you flip them though?
That's when you're solving.
Oh.
We're not solving right now.
Oh.
We will number 2. Yeah, and the reason why you would flip them is because you're setting each factor equal to x, and solving for x meaning that you're doing the opposite sign, right? But for now we're just factoring, we're not solving. And there you go. That's all you do. Now some people like to do this. Let me go and clear. So remember we pull out the 3x already, but x squared plus 5x minus 14. Some people like to do this. I used to teach it this way when I taught Algebra 1. Some people like it. I'll leave it up to you. So they'll put x squared here and -14 here. And then actually, I think I'm messing this one up. Oh, then they'll do this. They'll do you still do the diamond, -14 and 5. We had 7 and -2. So when you do this, what this really is doing, it's splitting the 5x, because 5x gets split into 7x and -2x, right? Because 7x and -2x is 5x. What can you factor out of the first row?
S.
What can you factor out of the second row?
7,
Okay, now the columns. What can you factor out of the first column?
x,
What can you factor out of the second column?
2.
Done. X plus 7x minus 2. Obviously, seems a little more work compared to what I did before, but when you get to the more advanced ones, this method could be good. We'll see if you guys like it. I'm not explaining this method really well, so I'll come back to it when we get to more advanced ones. But what you could do is you could put the first term in the upper left box, the last term in the lower left box, sorry, lower right box, and then when you do the diamond, you put them in the other two boxes, but you put x's next to them, and then you factor along each row and each column. That's another technique that you could do, especially when you get to problems like this one here, 4b, which we're going to talk about in a few minutes. So I'll come back to that in just a little bit. Okay, let's look at part C now. Wow, it's good. Yes, there's a way you could get some. I don't know how to do exact, but I think there's a way you could. I'm not 100% sure how to But if you want to work on it, that'd be cool. That'd be crazy. Okay, anything common here for part C?
Y
And what else?
2.
Good. Now, could I go any further? The x squared plus 4? I could.
Plus 2 plus 3. X plus 2.
Are you sure? Are you sure?
Yes.
Okay. Here's the problem with what
Oh, yeah.
okay. The problem with this, if you were to come back to the original form, you get a different answer. You would not get the same thing. That doesn't work. What if
No, that's no.
someone said -2, but then this would get you back to x squared minus 4, right?
It's just x plus 2.
It's just you're just x squared plus 4. You're just done at this point. There's nothing more you can do. So there's no such thing as sum of two squares. You have to be very mindful about this, because what if I were to plug in, like what if I had 3 squared plus 4? I know that's going to be 9 plus 4, which is 13. If I decide to break that down as x plus 2 times x plus 2 and plug in 3 now, I don't get 13. I get 25. So that's clearly different than this. Those are not the same. So you can't assume x squared plus 4 is going to be x plus 2 times x plus 2, because what is x plus 2 times x plus 2? It's x squared plus 4x plus 4. So those are not the same. So
Like not to do it.
there's no such thing as sum of two. I'm just telling you right, there's no such thing as sum of two squares. It's just, there's a difference of 2 squares, but not sum of 2 squares. There's no such thing. Actually, Haley, let's do this. You asked a really good question. How would you really know? Well, let's do the diamond method. Let's try the diamond method. Okay. So really, this is like saying, I know I'm going a little in the deep end here, but I think it's good for you guys. That's the same thing, right? There's no x in the middle, so I put 0x. That's a true statement. These are the same, obviously. So your b is 0, and your a times c is 4. Now let me pose this question to you. Can you think of 2 numbers that multiply 4 and add to 0? No, it's impossible. Actually, technically you could. Those are called imaginary numbers, which we'll cover in the second half of chapter 4. There are no real numbers. There are no real numbers that can multiply 4 and add to 0. So you can't do it, you're done. That's how you know. That's how you know. So I'm glad you asked that question, because how do you know? I don't want you just memorizing. I want you to apply a process, right? Okay, let's keep moving, guys. We're doing great here. Now, if you're asked to solve, you just got one extra step. After factoring, you set each factor equal to 0. After factoring, you set each factor equal to 0. So it's just the same we've done before. Not that hard. If you want to do the diamonds, that's fine. But the bottom line is this: what 2 numbers multiply to 81 and add up to -18?
9.
But both are negative, right? Yeah, exactly. No, that's good. You said 9, but just make sure you make both negative, right? No, you said 9. I'm being technical. All right. You did? Okay. I won't. I'm not going to worry about it. Sorry, I'm just being a little snide. You're too easy, Patrick. All right. So you have x minus 9 times x minus 9. Right. Okay. So you got that. And by the way, when the leading coefficient's 1, you can immediately go to the factor form, because if you FOIL, remember FOIL means first, outside, inside, last. It's an acronym. If you were to FOIL it, you would get back. If you were to FOIL it, you would get back to the original form. So FOILing is not factoring, guys. FOILing is the opposite of factoring. You FOIL to check to see if your factoring worked, to see if you did it correctly. That's all. It's kind of like if you multiply 2 numbers, like 5 times 4 is 20. Well, 20 divided by 4 is 5. I know I did multiplication correctly because I did the inverse of multiplication. Just FOILing is the inverse of factoring. All right. Anyway, now I've got it factored. What's the extra step here? Set each factor equal to 0. Because they're both the same factor, I only do it once. What does x equal? Done. That's simple. And why do we set each factor equal to 0? This is a very important part. I don't want to gloss over this, but you know, and it does need mentioning. This is called the 0 product property. Good. Yeah. Actually, I know that Ms. Buckley beat this into you guys. So I was sitting here doing my work and she was talking to you guys about it. And here I am talking to you guys about it. And or whoever you had for Algebra 1 in middle school or 0 product property. Think about it. Is this a product? Are you multiplying two things here? You bet. What's the actual product? Is it 0? You bet.
Oh, because 9 minus 9.
Exactly. So each factor has to equal to either this has to be 0 or this has to be 0. Because this here's the kicker, guys. I need you to pay attention. Anything times 0 is what? Boom. Boom. Got it. So if that's 0, the equation is going to work. Or if that's 0, the equation is going to work. Because we set up as a product. This is why we have factoring, so you can actually solve equations more easily. So x is nice. Let's try it again. Repetition is good. Repetition is a good thing. Let's do another one. Okay. First of all, what you want to do is collect all terms on one side. Okay. Collect all terms on one side, which I did. I moved all terms on one side. Let's do our little diamond, if you guys like that. But you know, if you just know that's hey, more power to you if you just know how to factor it. What two numbers multiply -63 and add 2 AJ going? Close, other way around. Not 9 and -7. Because
-7 plus 9.
no, you got to collect all terms on one side first.
Oh, I just put negative x.
Okay, but if you did that, you then have to factor as negative first, which you didn't do yet, right? You got to pull the negative, and when you pull the negative, then you get x squared plus 2x minus 63. Yeah, I'm actually glad you did that. Nothing wrong with what you did, but what you're doing is you're creating extra work for yourself. So some people will do this. They'll move the x squared over. That's okay. There's nothing wrong with that, but you have to pull out the negative before you do the factoring because the diamond method won't work. So you do have to pull that out. Actually, you're not technically wrong because then there'll be -2 down here, and so you did have this. It just makes it a little more complicated to do the factoring. So I would much prefer you keep x squared positive. You're going to be less prone to making an error because the more steps you have, the more likely we can make mistakes, right? It's like if you're making a big recipe, like a simple recipe, like 3 or 4 steps, you're not going to botch it. If you got to make something that's got 10, 15, 20 steps, you're probably going to screw up if you're not careful, right? I know I would. Yeah. So anyway, now either this has to equal 0 or either this has to equal 0. Of course, x would be -9 for the first one or 7 for the other one. So you get 2 answers, -9 or 7. Either one would make the equation work. Elizabeth, go ahead.
I have a question. Like I'm showing my work
See?
on homework. Is that enough?
Oh, perfect. You're great. Yeah.
I don't have to write like x.
I'm just doing this just to make sure I'm clear on what I'm doing. But it looks like you got it. You're good.
So it can be either answer, it's like an or thing.
Exactly. So x equals either situation because either one would make the equation true. If I were to plug, actually, we'll try it out. If you plug in 7, that's 49, right? 7 squared. -2 times 7, -14 plus 63 will be 49. If I plug in 9, that's 81. Sorry, -9, that's 81. -9 here, that's 18 plus 63. So I know it works. So guys, another thing too, check your work, plug in numbers, make sure left side equals the right side. That's a good strategy. All right. Okay, now, number 3 is just review. Okay, in case you guys forgot, quiet down, please. In case you guys, I've mentioned it before. And I'll be honest with you too, when I was in high school, I just kind of, some of my teachers say foil. I'm like, okay, I guess like aluminum foil. Like, what do you mean foil? You just do it. It is an acronym. And I'm glad. Actually, speaking of which, this is gonna really blow you guys' mind. When you guys had your freshman orientation, you didn't have one, okay? Because it was pandemic. It's pandemic. You're a junior, right? Did Rich Dioli speak to you guys?
Yeah.
And did he say how like this is like the second happiest place on earth?
Yeah.
Okay. Thank you. I didn't know that until like my 10th year here. SHP, Sacred Heart Prep. That's SHP.
Wait, second half.
Second
Oh, what?
happiest.
That's crazy.
I just realized.
Oh, I just thought you just said that.
Because like Disney, I think Disneyland's the happiest place. We're after Disneyland, right? SHP.
Wow.
Just so you know, Rich Dioli is a master marketer. Look at this building. $100 million he raised. Homer, he did it during the recession in 2008. $100 million. So it's done it twice. No, the $100 million went, most of it went to this building. The other parts went to scholarships, building endowment, and teacher salaries. But this building costs a lot. Like construction's at an all-time high. But in 2008, when construction was lower, we rebuilt the whole lower middle school, Homer building, all the athletic fields, and then remodeling Main and the previous building. He's done that twice in 10 years. And that's pretty amazing. What was that? Yeah. So anyway, he's a master marketer, just so you know. So, okay. So anyway, foil. Last, sorry. And I digressed. But yeah, sadly, I didn't get that until like a few years ago. that's what when we said, that's why he says that. Okay, first, outer, inner, last. Okay, so let's do it. First is 3x times x. Outer is plus 3x times -7. Inner is 1 times x. And last is 1 times -7. So you got 3x squared minus 21x plus x minus 7, or 3x squared plus 20. There we go. So 3x squared minus 20x minus 7. Oh, bless you. Yeah. I'm gonna get there in a second. It's actually the diamond method we've been doing all along. Yeah. Yeah. Okay, any questions on number 3? We're okay? All right, let's keep moving to number 4. Now, this is a more advanced. So the AC method is basically a diamond plus a bit more. So what you do is you put A times C up here and B here. So what is A? What is B? What is C here? So what's A, guys?
5.
And B?
-7.
And C. Okay, what's A times C here?
30.
And -17.
15 -2.
Good.
Or wait.
No, you got it.
15
No, you got it. Yeah, you got it. Okay. Now, hopefully we're okay so far. We identified A, B, C. Right, that's easy.
X minus.
I multiplied A times C, which is 30. Guys, quiet, please. I put B down here. Hugo, so helpful, gave us 2 numbers that multiplied 30 added to -17. So you have -19, -15. Now here's the problem. And when I've taught Algebra 1, I've had some students, they'll do this. They say, oh, I'm good now. The answer is x minus 2 and x minus 15. And they just go off the merry little way. I'm like, yeah, I got it. Yay. No, you didn't get it. You're way off. Because that is not the same as that. If I were to FOIL this, that's x squared, not 5x squared. So you can't do that. There has to be more you have to do. Here's what you could do. I'm going to teach it a couple ways. You choose what you like. So once you do this, and by the way, all this ever does, this part right here, all this is doing is splitting negative 17x. That's all it did. Negative 17 is negative 2 minus 15, right? We know that. So what you could do, and it's again, I'll do a couple ways. You could rewrite your expression like this.
Well, that's weird.
That is the same. What I wrote in pink is the same as Vertex, right? Those are the same. Now, this is the part that will be very helpful when you're doing this process. This is called factor by grouping. What can I factor from the first group? And what's left behind? Okay, what can you factor out of the second group?
3.
Well, we'll do negative 3. So you get the same thing.
Oh, I remember that.
Mhm. Doesn't matter. It won't matter. It won't matter. You can do any order.
Easier.
So now, are these identical? These 5x minus 2s?
Yeah.
So you can say the final answer is this.
Like,
Because x, guys, and I need you guys to put this. X and negative 3 are both being multiplied by 5x minus 2. Because x is being multiplied by 5x minus 2, negative 3 is also being multiplied by 5x minus 2. You pull out the 5x minus 2, you don't have x minus 3. So 5x minus 2 is a group being multiplied by x and negative 3 that I can just throw out and leave behind the x minus 2. So you can do it that way. That's one way you can do it. I'm going to show you another way. No, Hugo, you said you have another way.
oh, it's probably the same. It's the one where you just go divided by a.
Oh, so you divide by, well, hold on. So explain that to me.
So go over, so negative 2 divided by 5.
You mean from the beginning you do that?
No, right there. So you have negative 2 and negative 15.
Yes, okay.
You just, divide them by 5.
Okay, so negative 2/5 and negative 15/5
Yeah, so
Okay.
15/5 can simplify.
to negative 3.
Yeah, so you have a negative 3, and then that one doesn't simplify, so you end up with.
Oh, I see what you're doing. So,
minus 2,
I-
and then you have.
so you get x plus 3 and, okay. So what you're doing is you find the solutions and then you're reverse engineering to get the binomials that they come from.
Yeah, you just go 5x.
Okay, that's cool. I won't teach that to the masses. It works for you. I totally get what you're doing. But it might, just some people might not be able to see all the steps. Especially if they might have like, issues with like executive function or organizing all those thoughts, but you can totally see that. Hey, that's cool. But let me give you guys another, and again, that's quite clever actually. But here's another way we could do it too. So we had this again, right? 30, negative 17, negative 2, negative 15. This is what I got this from a math conference, actually in Carmel, which was a really nice conference, Pacific Road to be exact, but many years ago. So what you do is that after you split, you're going to rewrite this 5x squared and 6, and you're going to put negative 2x and negative 15x. So 5x squared is just borrowed from here, right? 6 is borrowed from here, and then negative 2x and negative 15x come from this. Now, factor along each, factor along each row. What can you factor out of the first row? We can factor along the second row. We'll say negative 2 because there's a negative that's first. We can factor out the first column. We can factor out the last.
3.
Yeah, we'll say negative 3 because you see a negative right here. So 5x minus 2, x minus 3.
That seems much easier.
It's nice. It's organized. The only thing that's the little nuance that you have to be mindful about, when you factor along the row, if the first term is negative, pull out a negative. Or you factor along the column, if the first one is negative, pull out a negative. That's the only kind of nuance you have to be mindful about. But otherwise, it works all the time. It's very organized. It's clean. So I don't know what you guys like in general. It's up to you. The first way was that's factor by grouping. It can get a little messy. But if you like the box, hey, go for it. Yeah. All right. Just a bit more. I'm not gonna do the word problem So we'll just do a couple more and then we'll stop. So we're,
The word problem, it says, you want to double the set area by adding the same distance.
actually, I think,
Like the width, what does that mean?
I don't know. I think it's a bad word problem. So we'll do word problems another day.
It's just that, like, don't you just double it and then that's, you know, you just go 24 by 10 and then you just do that times 2.
Ye-
And then you just get the double.
Well, the area will be 480 because right now the area is 240. So now you want the area to be 480.
Yeah, and then you just add it, right? So there's no-
Well, then you do 24 plus X and 10 plus X.
there is no-
And then you FOIL and set equal to 480. And then actually it's not a bad word problem, but we won't do word problems today. Okay. So let's look at this one right here. Actually, let me come back to my flow chart. Let me show you how to use the flow chart. Okay, so right now I have 3 terms, right?
And what I have, I'll try to board. 9y squared plus 12y plus 4. Is that correct? That's what we have, right? Okay. Is there anything common among these 3?
3, 4.
No,
No.
no, nothing actually. No, that's usually the 9. So nothing, that's okay. No worries, we'll go down this way. Now, this is the part that's important. Is the first one perfect squares? 9y squared perfect?
Yeah.
Is the last one perfect?
Yeah.
Yes. So what you could do is you factor it like this. You don't have to do the diamond. That's why I'm going to put this flow chart for you guys.
Now, if you did a diamond, there's nothing wrong. You still get the answer, just more work. You can totally do the diamond method if you wanted to. But I'm just going to go straight up and just say 3y plus 2. Actually, both plus. They're both plus because you have positive everywhere. Yes. Now, if the middle is negative 12y, then you do a minus. If the middle,
Ignoring the 12.
you don't ignore it. The 12 was already taken care of. Because so let's check our work. How do you check your work? You FOIL, right? If you were to FOIL, what's 3y times 3y? 9y squared. What's that? That's 6y. What's that? 6y. What's that? That's 4. If you clean it up, you'll get back to the original. So 12y was taken care of. It's just hidden.
Oh.
It was taken care of. You just don't see it. Yeah, so you can write like this, or you could write like this, 3y plus 2 raised to the second power. Either way is fine. I don't care. Again, you could do the diamond method and the box. But you probably made careless mistakes somewhere along the way. I'll look at your work. Yeah, you tell me, Matt. All right, last one, guys, and then we can do some practice problems. All right. 8c squared plus 38c minus 10. What's a, b, c here? 8, 38, negative 10. So you get negative 80 up top. 38 down below. It shouldn't be too bad. What 2 numbers multiply negative 80? Go, AJ.
40 and negative 2.
Yeah, 4 and negative 2. Now, here's the thing. Yes, that's a little trial and error because you got to kind of find pairs of numbers that make this work, but not really if you're methodical in your approach. What if you do negative 1 and 80, negative 2 and 40, negative 4 and 10, negative 8 and 10? Ultimately, you're going to exhaust all the options if you go in numerical order, right? So if you go in numerical order, start with 1 and the number itself. If you don't hit it, then it's not factorable. Then you're done. It's not. You can't factor it. Then you have to do quad form or something else to solve it. You set equal to 0. However, just be methodical in your thinking. We minimize the trial and error process. Alex, go ahead. You are right. I should have done that. Look.
What?
Ah, Alex, you should have just interrupted me. There we go. Okay. Okay, let's do it again. That's okay. Let's try again now. Let's do negative 20 and 19. I know it's going to be negative 1 and 20. So we got that look better. It would still would have worked. It would still been okay. But yes, I like the fact that you corrected me there. Thank you for that.
What if there's a negative in like the second box? So it'd be like 8c squared
Mhm.
and negative 2c trying to
Yeah, she didn't do anything.
Well, I mean, then you put a negative down below if your b is negative. You just got to find 2 numbers that add up to a negative value. So hold on, we're almost done. So you have 4c squared here and negative 5. And then I'm going to put negative C and 20C. Because remember, we split the middle term, right? Now, what can you factor on the first row, guys? What can you factor on the first row? For, how about the second row? -1. How about the first column? Just C, right? And how about the last column? 5. 4C minus 1, C plus 5, and you have 2 on the outside. And it works out.
Wait, I have a question.
Mhm.
I didn't like the factor you didn't.
You didn't factor the 2. Okay, so if you were about to go down the same path where Alex corrected me, you can factor out 2 afterwards. Afterwards, right? Here.
Then it would be 2.
Yeah. Right. Yeah. No, you've been fine. Just you gotta remember to factor out the 2 afterwards. Yeah. That's all. Okay, cool. So I'm gonna go over the homework in just a bit, but for this class, it's a lot of problems. So I think what I'll do is I'll probably assign maybe odds. I think I'll probably have you guys do, there are a lot. So we'll do this. We'll do 4.3, number 1 through 11 odd. 4.3, number 1 through 11 odd. 4.4. Also number 1 through 11 odd. Before you guys get too carried away, any questions about 1 to 10 all from the graphing that you guys want to ask about?
It was awful.
It was awful, no.
I don't know how to do it.
The graphing, yeah.
I just want to focus on the last, like,
Okay,
3 problems.
right here. Okay, that's right in vertex form. So your vertex is 4, 3. And here are your x-intercepts. So does that make sense first?
Yeah.
Okay. Well, so for now, because you have a negative for A, the graph's going to probably look something kind of like this. So you have a maximum value of 3. And then your x-intercepts are -1 and -7, right? So the x coordinate of the vertex,
For 1 through 8, do you want us to solve or do you want us to just?
it's factor. Because it says factor, right?
Yeah, but it's.
You want to still go ahead. I'm not going to hold you against you. So because you have -1 and -7 as the x-intercepts, because it's in factor form. So -4 is right down the middle. Now plug -4 back in. You'll get -60. And because the graph opens up, because A is positive, it's going to look kind of like this. So you have a min of -60. That's how you do it.
I think both like that you should
So, yeah. Okay, guys, let's get to work. I'll come around and help you guys out. Yeah, just right here.
Do you care if I do the first?
So I think the first thing you want to do, the first question you should ask yourself, this is probably where you're stuck. What form am I given? I'm given vertex form for the first one, for number 9. So if I'm given vertex form, I can immediately identify the vertex 4 and 3. Because it's x minus h squared plus k, right? So h is 4, k is 3. So the vertex is 4, 3. Now the vertex is either going to be a low point if the graph opens up, or a high point if the graph opens down. Well, my a value is negative, right? So the graph is going to open down. It's like frowning. It's sad. It's negative. Think of that way. That helps. So the vertex is the high point. So we have a maximum value of 3. That's a maximum y value that the graph could hold. Now for 10, what form do I have? I don't have vertex form anymore. Intercept. What are the x-intercepts? -1 and -7, right? Because that's what makes each of those factors 0. If you have 2 x-intercepts, the vertex can be right in the middle because of symmetry, right? So -4 is the x coordinate of the vertex. I don't know the y coordinate, so I got to plug -4 back into here.
Oh, you plug in the 4.
The -4.
No, okay. I thought you could do 1. I don't know why.
Let me stop.